Hello everybody, all my dear learners. Now let's see one more important topic as far as ADAS is concerned, which is called over the air. This is a very state of art technology that came into existence only after Elon Musk released Tesla into the market. This is a very modern technology and this is a very interesting, beautiful technology. I am sure you will enjoy learning about this. And before we go to read about this over the air in the context of ADAS, I will try to explain to you what is meant by over the air in the first place. What is meant by this over the air, acronymed OTA or called OTA in the first place. Okay, here I go. First of all, this over the air technology refers to wireless transmission and reception data, software updates or configuration settings to devices such as smartphones, IoT devices, vehicles and other embedded systems. Okay, understand this. It refers to wireless transmission and reception of data to devices such as smartphones or vehicles. Because we are concerned about vehicles, let's understand that wirelessly transmitting data to the vehicles is over the air. Instead of requiring physical connections like USB cables or manual downloads, OTA enables seamless updates and remote management via wireless networks. It may be a cellular network or a Wi-Fi network or a satellite, etc. Now, what is this OTA? To elaborate further, OTA technology is crucial in modern computing and telecommunications because it allows manufacturers and service providers to deliver software or firmware updates without user intervention. So, even without the intervention of the end owner of the driver, because I'm trying to explain you in automotive context. Without the driver intervention, a software can be updated. It can also be used to fix the security vulnerability promptly, enhance device performance with new features, reduce operational costs by eliminating manual updates. Okay, now what are the various types of OTA updates? OTA updates can be categorized based on their purpose and scope. First is firmware OTA. What is this firmware OTA, which is acronymed FOTA? Updating the device firmware, low level software controlling the hardware. Firmware is nothing but low level software, which actually is the software which interacts with the hardware. Okay, anybody who knows about the ECU knows that software sits on the hardware, and within the software the lowest level which directly touches, so to speak, the hardware is called firmware. And it is also used in IoT devices, smartphones, automotive system. For example, Tesla's car updates. Now it also requires careful validation to avoid bricking devices. Okay, now when it comes to software OTA, SOTA updates the operating system or applications common in smartphones, smart TVs and tablets, and it can be incremental or full system updates. Okay, application, it is always the top layer of the software. When the software is sitting on the hardware, application is the top layer of the software. So updating the top layer of the software is called SOTA or software OTA. Now when it comes to configuration OTA, it pushes settings, network parameters or security certificates. It is used in industrial IoT and telecom based stations. Okay, now coming to security OTA, it patches vulnerabilities without requiring a full system update. And it is also critical for connected cars, medical devices and critical infrastructure. Again, security, the word itself clearly explains that it is very critical for connected cars, because uh, in the session about cyber security, it is very clearly explained how the connected cars are vulnerable to security attacks. Now let's see how this OTA works. What is the technical breakdown or methodological breakdown of how the OTA works? The OTA update process involves multiple stages. A. Update preparation. The update creation, developers compile and test the update, which includes the firmware, software and configuration. All right, and next is the update is packaged, signed and compressed. So after the update is developed, it is first packaged, signed means it has some kind of password or some kind of security code, and then it is compressed. Now after it is compressed comes the next step, which is update hosting. The update is uploaded to cloud server or contact delivery network. Okay, and after that after that the global availability is ensured with low latency. Okay, low latency means it is update without any time lapse. Now next comes the update distribution. Coming to update distribution, device polling, server push, devices periodically check for updates. Alternatively, the server pushes updates to devices. This is the push model and this is the pull model. Okay, so here the devices themselves check for the updates, and here the server pushes for the updates. This word pull model and push model are self-explanatory. Next comes the download phase. The device downloads the update over Wi-Fi, cellular or satellite, and this uses the delta updates, only change parts to save the bandwidth. So wherever a small change is required, which is addressed as delta updates, to save the bandwidth, only the small change is addressed. Now coming to the update and validation and installation. Okay, first is to check the integrity. Follow this very carefully. I spoke about the port A, port B, and now coming to the port C. First you check the integrity, you check the digital signatures, verify the updates authenticity. Next you check the checksum and ensures no corruption. Next is installation process. For critical systems, a dual bank A-B mechanism is used and the update installs in a secondary partition. Alright, if successful, the device boots from new partition, else it rolls back. This rollback is nothing but going back to the old version. So during installation process, if the installation is successful, the device boots from the new partition to the new version. It boots to the new version, else it rolls back to the old version. Post installation verification. The device confirms successful installation. It reports back to server. It reports back to the server for analytics and compliance tracking. Key components of OTA systems. An OTA ecosystem consists of component and also function. Now we will see elaborately what is the component and what is the function. Okay, OTA update server is a component and it hosts updates, manages device authentication and tracks deployment. Next comes the device management platform, which controls which devices receive updates. Next component is security layer. This ensures encryption, digital signatures and anti-tampering. Now if you have any doubts about this encryption, digital signatures and anti-tampering, I thoroughly recommend please go through the video about automotive cyber security. Okay, in that module, clearly the importance of this encryption, the digital signatures is elaborated. Now coming to the device client, embedded software that handles downloads, verification and installation. Last but not the least, reporting and analytics. It tracks success, failure rates, device health and compliance. So this is, it clearly tracks the success and failure rates. It gives you a track record, how many updates happened successfully, how many had a rollback to the previous version and how many failed. To continue further, we are going to see the various applications of OTA technology. Now, what are the various applications? First is the consumer electronics. For example, smartphones, Android, iOS use OTA for operation system updates. Next is smart TVs like Netflix, Samsung, LG push firmware updates. Now, these are all already in use in smart TVs. And next is the wearables. In wearables like Fitbit or Apple Watch research, it receives feature updates wirelessly. Okay, so next comes the automotive industry. Now, the automotive industry, Tesla, it is famous for auto updates, improving autopilot and battery performance. Especially for these two features, the over-the-air update is very famous. Next comes the traditional automakers, BMW, Ford, now support for OTA for infotainment and engine control. Next comes the Internet of Things, for example, smart home, industrial IoT. Well, in smart home, Nest thermostat, ring bell update, firmware, industrial IoT, factory sensors, robotics receive remote patches. And coming to the telecommunication, cellular base stations, 5G networks use OTA for configuration, and satellite communication, SpaceX Starlink updates satellites remotely. Alright, so this satellite communication is a very state of art or a very modern thing. Again, SpaceX, which is promoted by Elon Musk, it updates the satellites remotely. And when it comes to healthcare, medical devices like pacemakers, insulin pumps, they receive critical security patches. Even over the air is helping the medical devices to receive the most state of art or most latest version of the software over the air. Now, what are the various security considerations? Since the over-the-air updates can modify critical systems, security is paramount. And let's see what are the threats and what are the mitigation strategies. The first threat is man-in-the-middle attacks. Man-in-the-middle attack and mitigation strategy is end-to-end encryption. And coming to malicious updates, the mitigation strategy is code signing, hardware-backed security boot. And rollback attack, this is also a very notorious threat. And coming to rollback attack, version checks to prevent downgrades, and denial of the service, rate limiting and staged rollouts. Now, considering these challenges in OTA deployments, now here we will see the challenge and also the solution. Bandwidth constraints, delta updates compression. Okay, this is the solution. Next is fragmented device ecosystem. The solution is custom update clients for different hardware. Battery and power management, and the solution is schedule updates during charging idle times. And last but not the least, the regulatory compliance. This is the most important challenge, and the solution is to follow standards like ISO 21434, which is the standard for cyber security. And let me reiterate the module of cyber security, in which you find very clear-cut elaboration of the cyber security, both for automotive and also for the ADAS context. Now, coming to the future trends in OTA technology. First future trend is 5G enabled OTA, faster, more reliable updates due to ultra low latency. Now, as you know, most of the mobile communication is happening at the 4G level. So once this 5G level also becomes regular use, then 5G enabled data is definitely going to be implemented. Next comes this AI driven OTA, predictive updates used on device usage analytics. And next is the blockchain or the OTA security, which means that immutable logs for update authenticity. Okay, so as and when there is updates, clear cut logging, clear cut track record, or it is like maintaining a register for the various updating. Now, coming to the edge computing, very many local servers reduce the cloud dependency. Alright, so edge computing is nothing but updating a software from very nearby source, from a local server, so that it did not go to the extent of cloud. Usually the software is directly updated from the cloud to the device, but edge computing means updating the software from the local server to the device. Now, in conclusion, OTA technology is revolutioning how devices receive updates, ensuring security, performance and longevity. So previously, if there is any software update, you had to take the device to the dealer or service station. Now, OTA, with the help of OTA, you are receiving updates directly sitting where you are. From smartphones to autonomous cars, OTA eliminates the need for manual interventions while enabling rapid features. So this is a huge convenience. Okay, this presents a undeniable convenience for both consumer and also for the OEM, or the device consumer electronics seller also. Okay, as IoT and 5G expand, the OTA will become even more critical, driving innovation in wireless software management. Now coming to the automotive industry, well, vehicle software updates, modern vehicles, especially electric and connected cars, use OTA to update software controlling everything from infotainment systems to advanced driver assistance features. Alright, so whether the software is controlling infotainment system or body control module or transmission control module, the software can be directly updated into the vehicle without the necessity of the vehicle visiting the dealer or service station. Now coming to the remote diagnostics and predictive maintenance, over the air enables real-time monitoring, diagnostics and predictive maintenance, enhancing vehicle reliability and reducing service visits. Now coming to the fleet management, fleet operators leverage OTA for remote monitoring and maintenance scheduling and efficient resource management. Now this is a very important application of OTA. Okay, by remote monitoring and keeping a track record of the various vehicles in the fleet. Thank you.